you very much, Andreas, for the invitation. Thanks for everyone who's here. I had intended to do this in German, but I think if this is going to be published on YouTube, it may make more sense to do the presentation in English. So I'll keep the slides in German, and I will try to not screw up too much doing this presentation in English. So what I want to talk about today is actually an application of LoRa. You're all up to speed now on how this technology works, how to use it, what's behind it. I want to talk about an actual application that we developed at where I work at the Bern University of Applied Sciences, which was about measuring the soil moisture content in protective forests. A few words about my background. I'm originally a wood scientist, so I have actually no electronics background. And however, for the last couple of years, I've been working in industrial automation, serving mostly the wood industry. And as part of all of that, IoT became a topic, and then we ended up doing with our colleagues from a forestry science group this project that is about protective forests. First of all, maybe a little bit of context on why we do this whole thing. What is a protective forest? We have this situation in Switzerland quite often that we have a mountain with a slope. This is, I think, quite common in this country. And what happens is that up there in the mountain, we have a natural hazard. To put it bluntly, a natural hazard in that case is whatever can fall down from the mountain. It can be rocks, it can be bits of the mountain, it can be snow in winter, it can be all other sorts of things. And then down here, we often have a damage potential. This can be a village, this can be infrastructure, this can be a road, this can be a railway, things like that. So things that can break, things that can die. And in between, we have what we refer to as a protective forest, and I think sometimes protection forest is also the term. The German Schutzwald is actually it's a well-defined term. In English, I think it's a bit of a mess. And as you can see here on the picture on the right, indeed, one thing that the forest serves is that it can kind of hold back these natural hazards that are coming down, like you see here. This is a bit of an extreme example. Typically, a rock like that would probably clear a bunch of trees if it manages to gain enough momentum. So we often have to help with bits of steel in our forest. But what's also important to understand is that the forest also serves to stabilize the slope, right? So all the earth that is there, all the small rocks that are there that would be washed down maybe during heavy rain, they are stabilized by the roots of the trees down here. And we are very much interested on the forest science end of things in protective forests for two reasons. On the one hand, there is climate change. We have increasing drought in summer. We are seeing this in forests all over the place. And so we want to maintain this protective ability of the forest for as much as possible. And the other thing that we try to understand about these forests is how they actually work and if they are more resilient to let's say, drought periods or things like that, so we can learn things from that for production forests that we use for timber. So this was the onset of our project a little bit, so the motivation behind it. We are not the first people to think about measuring soil moisture content. There is a project by ETH Zurich. This is the Swiss soil moisture experiment. And what you can see here is what they do is they basically also built a network, but of really huge sensors. So they have to dig a hole of about a cubic meter, a bit more than that, I think. And then they install a huge thing in there. So they get very precise measurements. However, I think you can imagine how much work this takes, right? And this is not something you would do. You would not deploy a couple hundred of these. And for that reason, wait, sorry. No, it works. And for that reason, we only have a handful of test sites from Swiss SMAX. And what you can also see is that only the green ones are actually in forested areas. Everything else is agriculture. And this is a typical situation. We do a lot more soil science too in agriculture because there is simply more money behind it typically. So in our project, we set out to do something. Again, bluntly put, we put quantity over quality. So we wanted to have small sensors that are easy to deploy, that are cheap, and that we can really deploy in a bunch of places. And the system architecture is pretty much what Andreas already, no, you did not manage that part, sorry. But the system architecture is typically is quite straightforward for what we did. We have a LoRa modem, we have some sort of microcontroller, then we have an AD converter and a sensor. I will talk about this a little bit later. And then we have some sort of energy source. So we opted for solar cells and a lead acid battery. And I admit this may sound like a weird choice because it's an outdated technology. But I think most of you may have seen those videos of cell phone lithium polymer batteries going up in flames in people's pockets. And this is certainly not something that we would like to introduce into a forest during a drought period. Where the fire hazard from the forest side is already high, we don't want to add to that. And the other thing is, since we are out in nature, it can get cold, and most of the lithium-based batteries don't really like to be charged in sub-zero temperatures. There are special ones, I know. So we really went for lead acid because it's robust technology and they're very hard to kill. The other architecture is what Andreas showed just before. Again, we have our sensor nodes and we have gateways somewhere, and we typically do not own these, so this is actually only our part. And then we have a server that we use to kind of gather data. These are servers that are provided by our school. We used TTN in the beginning and we use it wherever we can. However, in somewhat more remote areas, it may be hard to be next to a TTN gateway. So we also use a lot the Swisscom as a provider for the backhaul. Again, being a company or an institution, we can have a contract with them, and actually pricing is pretty reasonable. So it doesn't cost you an arm and a leg to use them. So in more detail, what do we use? We first went with ESP32 based systems. We then switched to these Heltec CubeCell boards. They are small, they're cheap, and they have the LoRa module integrated, and they don't come with all the fuzz of Bluetooth and Wi-Fi that we don't need anyway. Then for the soil moisture, we use these cheap capacitive sensors. The advantage of those is they're like 50 cents a piece or something like that if you buy them in bulk in particular. The disadvantage is you have to calibrate every single one of those. And you have to calibrate them for moisture levels and for all the soils that you need. So I actually figured out during the project how much of a mess soil moisture actually is. This is something I'm not going to talk about today, but we did some also robotic calibration on these things because we just had to automate the process. And then we use these also simple TMP36 sensors for temperature measurements, because this dielectric constant that this thing actually measures is also dependent on the temperature of where you're measuring. In practice then again, we did a lot of cabling. So we put our spine of our sensors together, then we pack everything up into something more compact. We opted to use these PVC pipes. These are just drainage pipes. They work really well. And this allows us to have really a thing that we can then install just with this hand drilling tool, Bohrstock. And then we just dump the earth that we took out back on it, and we're basically good to go. We hook up our solar cell, our brains of the operation, and we're fine. At least so we thought. To begin with, a technical challenge. Andreas has an excellent video on AD converters, and I hadn't seen that one back then. But initially I tried to be clever and use the integrated AD converters on the ESP32, and then what we saw is quite nice, is that we had in our moisture measurements, we saw these jumps. And what you can see is that they actually happen when one of the sensors hits 0 degrees. So I did not investigate this any further. I decided to just say we're not using onboard AD converters, and we switched to the ADS1115 for measurements. This one works really well, even in poor conditions. And then we deployed in November the first time our sensor, I think. Leonard, correct me? Yes. So you see here the terrain that we're talking about. If you think back of the Swiss S-Max picture, if you had to dig a 1 cubic meter hole in here, to begin with, you wouldn't be able to do so because there's only half a meter of soil down there. So the pipe that I showed you with 1 meter length was extremely optimistic from our side. With a lot of work, you can get 50 centimeters in there. And then we deployed these small boxes with, also we had self-made antennas to improve the signal strength a little bit. This worked quite well. And then we faced a couple more challenges. So one challenge is that you see this here, this used to be on a tree that was next to the sensor. This is a branch about this diameter, about 8 meters long. It decided to come down and hit one of our sensors. So this is what it looked like after being installed. This is the antenna, what it looked like after eating a tree branch. Well, this is something that you have to deal with, to put it simply. This is one of the challenges. Another challenge for us still is energy consumption. We still have a couple issues there that these things simply don't last long. We're on a north-facing slope in a forest with solar cells, right? And this is not great. So something that would work around here in the city, maybe, forget it there. So we're still tinkering on a solution there. With that, I would like to get to an end. We have a homepage for the project. This is the QR code leads there. And then at that point, I would also thank the team that I've been working with. So this is 2 colleagues from Havel that work on forest science, and Lennart and I are from AHB, from the Woodheads from BFH. And Lennart is actually also here in the public, so if anyone has questions, you can also ask him. With that, thank you very much for your attention, and if there's questions, either now or during the break.